How many of you participated in the Mega Millions Lotto a few weeks ago? I bought a ticket. I did not win. I assume nobody here won. I will say, even if I did win, I think I would still be here because I am really excited about teaching people and telling people about what this technology is. It almost feels like if you had a time machine and you can go back and tell people about the internet or what Twitter is about or Instagram and what that world, what our world is to people in the early 1990s or 1980s or something like that. So, going back to the lotto ticket, how is it that we buy these tickets and we assume or we trust that the government or the lotto organization is actually going to pay out, or they're actually paying out the right amount? So that was a $1.5 billion lotto. How do we know that maybe they actually sold $2 billion in tickets or whatever it is? So, how do we know that that's the correct amount? And the answer is, as I said, we trust. We trust this organization. We trust the New York Lotto. We trust whatever government agency that is running this. So a lot of services and applications that we use today is really built on this inherent trust that these different organizations, they build up over time. And obviously we do have a lot of trust in things that are government run. We have a lot of trust in other big institutions and universities. But can you imagine, but the fact is that it really takes a long time to build up that trust and to really establish that kind of reputation in whatever industry or space that you're in. But can you imagine trying to run your own lottery, put the legal aspect to this aside, imagine it is legal to start your own lottery, and imagine you want to do this in a way where people feel very confident that you are going to pay out what is supposed to be paid out, that you're paying out the right amount, you're not going to hold on to the funds and do this fairly. So it'd be really hard to start gaining trust, and this does exist, in online betting, different online gambling rather. So you do have different companies doing this, but it is really hard for everyone to really trust them. And there are scandals of these platforms scamming users where they're not really fairly paying out whatever it is, the roulette table, or I even saw an article where there's like a live video feed of an actual real person that's dealing blackjack. So you think you're dealing with something that's honest, but this dealer was able to sort of like cheat with the cards and like do a double dealing or something. So imagine you can create a lotto where you can get together 1,000 people, maybe it's 100,000 people, and everyone collectively is managing the funds. Everyone, you collect the funds and you're holding it together. I don't know what that means. Maybe you're holding it in a safe that has a million locks on it. So everybody has a key to one of the locks. And then you also pick a number randomly together, and then you pay out the winner as a collective. So you're doing this. There is no central organization that's managing this. You're just doing this as a group of 1,000 people or 100,000 people. And that seems like it's an impossible problem, right? It seems like a massive, massive communication problem, a massive record-keeping problem. Like, how are we all going to coordinate and all agree on what steps to do and what steps to take? And it turns out, the reality is this was an intractable problem to do. It's an intractable communication problem up until 2008. So there were a lot of scientists, a lot of computer scientists and cryptographers. They were working to figure out whether or not you could actually have a massive network of people, and the people are operating through their computers, and they have the computers all work together in a way so that we could actually create, for instance, as an example, just this lottery program. So it was technically not doable for many years until a blockchain was invented, and what I described is now actually doable. You could do, since 2008 or 2009, it's doable, and I'm going to walk you through that and explain really what the challenge was up until recently. So I'm Solomon Lederer. I am a blockchain educator, co-founder of Blockmatics. We are a blockchain training company. Simple. So the thing is, we are always used to any kind of computer communication that we are very familiar with is very much a client-server model. That is, you are communicating with some central authority, whether it's like you had a central authority with the New York Lotto Association, whether your central authority is Amazon, Facebook, whatever it is, you are just a client, and you're running a program that's called a client. Typically, a web browser is probably the most common client software. So all the heavy lifting is going on the right side there. It's, they're doing the data processing, they're storing all the information, and your side is just a window into what's going on. And that's whether or not it's a web browser or your, most of the apps on your phone, they're all just clients, right? Your Instagram, the Instagram app on your phone is doing something very, very different and a lot more limited than what's actually going on in Instagram's servers out there. That's what we're very used to. The alternative is what's called a peer-to-peer model or a distributed model. And in a peer-to-peer system, everyone is running the same software. The program that's on your computer or on your phone is identical to all the other programs in this system. And you are also helping all the operation within this network. A good example of this is BitTorrent. Yeah, it was used primarily, and it's probably still used for moving files illegally, music files between computers. But when a file moves between different machines, it's not like you're downloading it from iTunes, from Apple servers. The Apple server situation, that's a centralized model, again. But in the peer-to-peer model, everyone is storing certain files on their machine, and it gets routed with everyone's participation. Skype is actually another example of this. So very often when you make a Skype call, you're routed through other people running Skype software. It's a bit of a hybrid model with Skype. I'm not going to really get into that one. There are others, OpenBazaar, which is like kind of a peer-to-peer version of eBay. So in a blockchain is, again, another peer-to-peer piece of software. It's a piece of software that can, for instance, do this lotto thing that I was describing. One massive or special difference that it has from BitTorrent, for instance, is the idea that everyone has the same data. Like you get this record, and you're confident. Number one, you have a record that's the same as everyone else. Any change that happens to the record, you're also confident that everyone else has that same change to the record. So you can think of, we're used to, again, Google, let's say a Google Doc. That would be a centralized version. We can all connect to a single Google Doc and update it, but that's all happening in Google's servers somewhere. The alternative is, why don't we all just keep a copy of it? And you can cut Google out of the picture, right? And I mean, Google, this works great for a document like this, but I'm trying to give you, you can come up with a lot of examples where you don't want it to be some central authority. Or because for that reason, central authority only works when you start to build up trust in that institution. The Google Doc is a centralized model. The blockchain is a decentralized model. So everyone is, or distributed is another term. There's a slight distinction between the two, but I won't get into that. It's a distributed record-keeping system. That would be the short way to describe a blockchain. I will talk about later. It's actually more than just records, but it's also different rules and operations and commands or programs that you want to do on those records. So, as I was saying, with respect to like a lottery, there's a lot of rules in terms of how the money should be controlled, how it gets paid out to someone. You can write those rules into this record-keeping system. So the rules may be, you have a certain digital location within this network, within this blockchain, and maybe once 1 million tickets are sold, or once 1 million people put in $1's worth of some, say, a digital currency, then the rules of that program will pay out randomly someone. I'm kind of maybe glossing over some details there, but I'm going to try to really explain what the problem was, or why this is normally a really hard problem until blockchain came around. I do want to point out, so this idea of a client server, or the idea of having a distributed model, we don't really see distributed systems in computer systems very often, other than those examples of BitTorrent, et cetera. But there are distributed systems out in the natural world. I mean, that exists. So for instance, language itself is something that is considered distributed. There is no central authority that dictates what words get added to the language, how to pronounce words. You can have different groups in different places. They're just evolving it on their own, right, in a very distributed way. So that you could have, maybe from some central language, you have Latin, which develops into a whole slew of, Romanian, Portuguese, Spanish, Italian. All these languages can come from a single source because it is done in a distributed way. I just want to illustrate that distributed exists everywhere. So how did this first start? It was really, and when I say this first start, why was there so much effort to get a lot of computers to all be able to keep this record system where everyone is in sync? That's ultimately the problem that we're trying to solve with the blockchain, to get everyone in sync. And there was this mailing list, like this email list, of a lot of cryptographers, computer scientists back in 2000, in the early 2000s, and in 2008, there was this message that comes across this, this list by someone by the name of Satoshi Nakamoto, someone nobody had heard of. Well, you know him, but so nobody had heard of this character. And he says, all these cryptographers, they were trying to create some kind of digital cash system, like a eCash system, which by the way, I would say digital cash is very different from something like PayPal or Venmo or credit cards. Those are really, you're still, that's more like digital accounting, where you could instruct your bank or some other company, hey, debit my account, increment somebody else's account. But they were trying to create something where you can sort of like sending a digital photo to someone. Like I can send you a copy. I don't need to go to some other authority. So the same way, they want to be able to have like a digital dollar, so that whether it's some kind of unique code that you get, and when I send it to you, it gets destroyed on my side, something like that. Anyway, so this person Satoshi says, hey, I'm working on a new electronic cash system that's fully peer-to-peer with no trusted third party. And there's that word, peer-to-peer. Like I did this in a way that there doesn't have to be any central organizer. And these cryptographers, they pushed back, and they pushed back hard. They were like, this is not possible. And who are you to tell us that you did it? I actually have this book. It's called The Book of Satoshi, and it's actually a really cool book, and it has all those email exchanges between Satoshi Nakamoto and all these other cryptographers, where they kind of pummel him with one question after the next and say, well, it's not really doable, and it's pretty amazing how he was like one step ahead of all of them. He had a good explanation for every question that they gave him. And one of these cryptographers, which is actually in here, this guy James Donald, he says, well, the Byzantine generals problem is the classic hard problem of distributed data processing. And he's saying that you can't actually get a whole network to coordinate and all be in agreement on a single source of truth. Like you would not be able to get a network to agree, for instance, on who to pay out in this lottery system. And I'll explain why they thought you can't. And Satoshi replies, he's like, the proof of work chain is a solution to the Byzantine generals problem, and it goes on and on. And this chapter, by the way, chapter 13, is actually called the Byzantine generals problem. So that's really the crux of what a blockchain solves. I'm not going to be able to have time to actually tell you what the solution is. I'll leave you that as a cliffhanger. But I will walk you through actually more of what the problem is. This is a short talk. This stuff normally takes days to really get into and explain. But if any of you do want to actually know the solution, just contact me. I'm very happy to tell you all about it. And you can even email asksol@blockmatics.io, and I will respond to your emails. So what is the Byzantine generals problem? This is kind of this whimsical problem where you can imagine you have a number of these generals, and they're surrounding this medieval city, and they all want to attack. They want to take over this town, but the only way they can be successful is that they all go at the same time. So the night before, they're sending messages to each other. There's some generals that are sending a message by courier saying, let's go at 4 a.m. Some generals maybe will say, let's go at 5 a.m. And the problem is there is no head general here. They're all at the same. They're all in the same rank. So there's no one who can put his foot down and be like, well, we're going at 4. And then you have all these messages being passed around, and maybe some generals will be like, you know what, I changed. 5 o'clock does make more sense to me. I see more messages saying for 5, I'm going to go with 5. But then there might be some other generals that see the opposite. So they switch to the other side, and anyway, it becomes an impossible problem to all converge in what is actually called in blockchain. You hear a lot of this idea of achieving consensus, that you want everyone to have the same result. And the way this problem, the way it manifests itself when you're trying to create a digital currency or e-cash system is what is known as the double spend problem. So I'm going to explain the same problem when it comes to digital payment. So the idea is, on the left side over here, we have Tom. He wants to send some digital item. We're going to call it a Bitcoin. He wants to send a Bitcoin to, he issues a message to the network. He broadcasts out to everyone in this network, like you're using BitTorrent or whatever. You connect to all your peers, and they flood the whole system with this message, and he sends a message saying, I want to send my Bitcoin to Mike. But at the same time, he sends another message saying, I want to send my Bitcoin to Lisa. So he's either sending this maliciously, maybe it's just accidental, that there's just 2 of these messages that are going out. The problem is he only has 1 Bitcoin. He only has 1 to spend, and those messages go out. On the right side is our network, where we have a bunch of computers. These are called nodes in the system, or sometimes you would hear the term miners. And they hear these 2 messages. They hear both. The problem is they can't honor both. It's akin to if you write a check to 2 people for $500, but you only have $500 in your bank account. One of those checks is going to bounce, right? So the bank will decide, we're going to honor this one, reject the other. Maybe one just came in shortly before the other one. So that's really easy to do in a centralized system. Your bank can be the ultimate decision maker. But who's going to decide now in this case which transaction to go with? They're both equally valid. We just can't do both. It's very similar to this problem here. We can go with 4 o'clock or 5 o'clock, but it's only going to work if we all agree on the same result. And if I want to go back to this lotto example, we all have to agree on what the random number is, or what how we're going to pay out, who deserves to really get paid out. It's a coordination problem. And that is something that hasn't been solved. That is the core problem that's really challenged computer scientists for about 40 years until 2008. And this solution involves creating this record system, which is known as a blockchain, and each entry in this chain, in this structure, it gets packaged into a block. And a block is just simply a whole batch or a collection of different transactions. So all it is, it's like we don't just have this thing that's being broadcast. We may have thousands and thousands of messages that are being broadcast. And these computers, they hear about all these messages, but some may hear of one. I didn't really explain that. So what I'm showing on the right is that some hear of one transaction before the other. So the blue computers, they heard the transaction that he wants to send it to Mike first. And then the green computers, they heard the transaction that he wants to send the Bitcoin to Lisa first. So how do we get all of them to agree? So as I was saying, with the blockchain, they're all packaged in these blocks. And each block also refers to the previous block that has been created. So you can only add new information to the system. You can't delete it. And each block also has its own sort of like a reference number, ID number, which is known as a hash. And that's how these things are linked together, because each block would also include the reference number or the hash of the previous block. So the solution is, which I'm not going to get into the technicals of it, but the solution is that we want to design it so that only one computer, one participant in this network is able to create a block within a given time frame. What we do is we make it really difficult to create a block. There's a lot of kind of work involved. There's a lot of computational work that's involved in generating a new block. So instead of, like we go back to the Byzantine generals, they're all just passing messages like constantly all the time. If we had a mechanism to slow this down and make it so that in order to send a message out, it's really hard. You've got to go through a lot of computational work first. Then, that will solve our problem, because on average, maybe only one general will be able to create a message within a given time frame, and that gives it enough time to reach everyone in the system. So this is more the technical side, which I told you before. I'll explain to you on the phone. So you have a new block that's created. We got a bunch of these transactions in there, and it has some other data. That hash number is really, like I said, that ID number for the block, and it also references the previous block. And it pushes that out to the network, right? It's sort of like the general sending the message out, and all the other miners or nodes in the system, they will see this block, and they'll be like, this is a good block. I like this block. Everything within it is valid. All those individual transactions are okay. It has this right hash number, which I'm not going to get into, and it references this new block references block 2, so I know it's sequentially it follows, it belongs over here, and then they will add that block to their copy of the record. Now the reason how this solves our problem is because whatever that miner wanted to do, or whatever transactions they want to include, as long as they're valid transactions, they can go in that block. So if we go back to that photo, this big picture here, one of these computers are going to be lucky in some sense, or be able to do the work before everyone else in order to create a block. And whatever computer it is, if this guy wants, they can just include the Tom sending the transaction to Lisa and push that out to everyone else. And everyone would be like, okay, we have the Lisa transaction in this block. We're going to go with that one. We're just going to drop, sort of like bounce that check. We're going to drop the Tom Mike transaction. Does that make sense? Any questions in that part? Because that's the super hard part. And in terms of, again, what that work is we just don't have time for that. But it's not easy to add data to the blockchain, but once data is added, then you're confident that everyone is the same. Now, the reason why this gets really cool is because those transactions, they're not just payments between different parties. It's not just simply being able to send, for instance, a Bitcoin. It can actually be, as I mentioned earlier on, different rules on how you want certain value or certain operations to be executed within this network. And you may have heard, have any of you heard the term smart contract? Is that yeah, it's a few of you. So along with blockchains, you're going to hear a lot this term, smart contract. Like you hear this again and again and again. Smart contract is simply a computer program that is running or that is stored in can be executed on the blockchain. And what that means is everyone in the network has a copy of this program. Everyone will execute it identically. Why will they execute it identically? Because if they don't, you're sort of just ignored from the system completely. It's almost as if you were trying to send an email, but you want to say, you know what, I'm not going to follow the email protocol. I'll just put in my own headers in this email. You're talking another language at that point. So you're just kind of like you're removing yourself from the system. So if you're participating in the system, you're going to execute everything the way you're supposed to execute it. Because everyone, again, is running that same software, this peer-to-peer software. So there's these programs that are on there, and you can now have a bunch of different users that are interacting with that program, and everyone can see exactly what the program is doing and have full confidence that this program is going to do what it was designed to do, or at least, if you can read the code or find someone or some company that can verify for you, yeah, this is a program that it does what it says it does. You can see the whole history of everything that it's done before. So getting back to my starting example, that program could be a lottery, right? So you can just write the rules, and people can send money, and in this case now we have digital money because we're dealing in this blockchain universe. They are sending money into the program. The program now is in control of it. It's almost as if you were to design a safe where, in my analog example, I said, imagine you have like 1 million friends and you all get together and you all put in $1 into your lotto collectively, and you put it into this safe, and the safe is designed that it will, on its own, choose one of the contributors randomly and pay that person. This is some fictitious safe I just made up. But that's what this program can do. It can keep a record of everyone that had now contributed. It can select a random number at some point, and then send all the funds to that person. Now, a lottery maybe is not a very exciting example, or the same thing would apply to any kind of betting scenarios, but it actually extends into real-world examples. So, and I'm not going to go into that, but there's something related to lottery and betting. It's called prediction markets, and this has like a very strong use case, which is very akin to this system. But it's not just lotteries and things like that. It can be any kind of business operation, which is everything you can put down in rules, any kind of contract. That's why it has the term smart contract. So it could be something like an insurance policy. You can have an insurance policy that if your flight is delayed by 5 hours or it gets canceled, you should get automatically paid out. You have this flight insurance. This actually exists already on the blockchain. So it's sort of an insurance product. And again, everyone is going to do this in sync. If there's anyone that doesn't, it's like they're taking themselves out of the equation. So you're getting a lot of this kind of built-in redundancy, a lot of built-in guarantees that the program that you put there will in fact execute the way, will execute. And no one can stop it. For instance, one of the big popular blockchains, Ethereum, it has something like 15,000 machines around the globe in every country that is running this blockchain. So even if you were to take out 1,000 of them, it won't impact the overall system. So these are I'm just put a laundry list here of some of the properties that a blockchain gives you, and you can keep these in mind when you start hearing the other talks throughout the summit, how the product or the service that is being offered benefits by using a blockchain because you get one of these properties. The big one would be this transparency and auditability. So anyone can see what is happening in this program. Everyone can see what it's done before. And I touched on point 2, that you have this incorruptible and permanent record. You can delete your own copy if you want, but again, it's only your copy. You can't delete all the other thousands of copies that are out there. Yeah, I won't go into all the others, but I'm going to leave it there. But you can If you want to know technically how the blockchain actually solves that problem, how it creates does that proof of work, again, hit me up. And I'll take, I think we have time for what, a couple questions?
Yes.
One or two? Yeah.
Yep.
All right, so if you have any questions, now's your time to look smart. Okay, if you think of any later, all right, we got some. Okay, I'll do the person who's closer to me first, and then the one behind you. Yeah.
Hello. Okay.
Yeah.
So I had a question about, can anyone create the blockchain in regards to for the hash and the accountability part, or does it have to be a specific person that can create the block? Reference.
Okay, I'm going to answer your question in a couple ways. So one is, can you can definitely create your own blockchain in terms of launching the software, but it's only relevant if you have other people to connect to. So it's almost like if you're trying to create your own Facebook, you could create your own social network, but then you need a bunch of other people to join it. But is your question in terms of can anyone participate and be involved in making blocks? That you could do as well. Yeah, you just have to download the software and yeah, and then your program will participate in the network. That answer good. Behind you.
Can you give an example of a really useful smart contract? That's like a real example.
Yeah, a very big one that has been used a lot over the last couple of years is a crowdfunding smart contract. So, I mean, we're all familiar with Kickstarter, Indiegogo, right? And these are platforms where people, they put in, they're trying to raise $1 million, and when they make the product, you get whatever the product is, or you get a t-shirt or something. So this has been done, or is being done now a lot using a blockchain, so that everyone, instead of sending your money to some company, you're actually sending it to a computer program that is on the blockchain, and you can see, as a contributor, you can see all the other people that have contributed, you can see how much they're putting in. You also get this automatic, but generally people are contributing to get other kind of crypto assets or crypto tokens or something, or some kind of digital thing, and that digital thing gets sent to you immediately. Like as soon as you send the payment in, the item comes back. So far, something like $7 billion have been raised using blockchain contracts this year, and $7 billion last year. So far, far more than Kickstarter and these other ones. Yeah, I think this will be the last one.
Like, since you can't edit the system, what prevents like a corrupted copy from being distributed, or
big problem, yeah.
Because once it's in the system, it's in the system.
Once it's in the system, it's in there. So there's new kind of programming paradigms that are now being developed in terms of how do you start developing code that can be upgradable in a blockchain scenario. So you can always deploy a new version. You cannot get rid of the old one. So yeah, if there's an old version that you did not also build in a mechanism to sort of drop that version. So generally they build software where you have this kind of wrapper, and then a lot of the internal functionality can be swapped in and out, so you could upgrade some underlying components. But if you don't design it that way, then you're out of luck. And yeah, that has been a big problem with blockchains, is that once there's a bug in there, potentially a lot of money can get lost, and a lot of money has been lost. So currently, there's, at the time, this past year, there was a bug which kind of accidentally removed or cut off one of these underlying components accidentally, and it was something like $250 million worth of cryptocurrency is just gone. It's like sitting there, but nobody can access it. Like the withdrawal mechanism was broken. So, yeah, just stuck. There's no way out. So I think should we take another?
One more.
One more, okay.
I'm sorry, this may be a little unrelated, but what's your opinion on blockless systems? Change like IOTA?
Yeah, sure. So there There are many different varieties to a blockchain, and some people even argue whether or not that really fits the bill of being a blockchain. But I agree, IOTA is another really great system that builds, or at least solves this problem. Ultimately, we're trying to just solve this coordination problem, this Byzantine generals problem. IOTA does do that, so even though it is organized very differently, it is really still, I would consider, blockchain technology. All right, well, you can ask me your questions after. I'm going to still be here for the next, well, until the end. So, thank you.